Alright, so we should have audio this time. I don't know why my microphone wasn't turned on for the last video, but that is what happened. My microphone was off. Okay, so we have two definitions that we haven't learned yet. Up to this point, you should have learned the main ones that we need, but we are doing a few more this time. So make sure you're following along. So first thing we have is what's called a polynomial in one variable. All this means is that I'm in the form of a sub n, so I just have some number x to the nth power plus some other number. It's just another number, that's all that means. And then I have it to the next power down, so on and so forth. So basically all this is saying is I have something like 2x to the fourth plus 3x to the third, and so on and so forth. So basically, it's just a polynomial with one variable. So a polynomial with one variable where there is no negative exponents and no coefficients. I'm just going to abbreviate that, of 0. I also will not have a exponent in the denominator, so I will never have something like 2 over a. That will not happen. That will not be a polynomial in one variable. So, polynomial function then is just adding in that I have the f of x is equal to a sub n x to the n plus a sub n minus 1 x to the n plus minus 1, so on and so forth. This definition then is the same thing. You just have to make it an equation. Otherwise, everything is the exact same thing, copied word for word. So that's why I just drew this fancy little arrow here rather than rewriting everything. So it'd just be like f of x is equal to 2x to the fourth plus 3x to the third, so on and so forth. So reading our definitions between here though, the degree of a polynomial in one variable is just the greatest exponent, so the highest exponent. The leading coefficient then, remember coefficient is the number in front, is the coefficient of the term with the highest degree. So it's just the number in front of the variable that has the highest exponent. So I'm going to take this x to the third here and write it up here because it's supposed to be one thing. I'm going to white that out, pretend it wasn't there. Then, so x to the third goes up here. And I'm going to white that out and pretend it's not there. Okay, so rewrite the expression. So the powers of x are in decreasing order. So I'm looking for the highest exponent to go first. This is known as standard form. So my highest exponent here is negative 2x to the fourth. My sign is going to come with it. So negative 2x to the fourth. The next highest one is my x to the third, so plus x to the third power. The next highest one is 3x squared. And then I'm left with this minus 7. So once I have it in standard form, I can determine the leading term. These are things that are important, what I'm highlighting. The leading term is just the front term once I have them written in standard form. So this is the first term in standard form. Remember, your terms are separated by addition and subtraction. If I had numbers in front of here, like 1a, then I would have a term in the front, but that term's not there, so I'm going to take it out. So my leading term then is the entire thing with its sign of whatever is in front of the next addition or subtraction sign. So my leading term here is negative 2x to the 4th power. Your leading term, if it's not in standard form, is the term with the highest exponent. So if I hadn't changed anything, my leading term would be this, because I know this should be what is in front when I use standard form. So if I hadn't changed it, I still know that my leading term should be whatever has the highest exponent. Step 3, the degree. Your degree, as we mentioned before, up top here, the degree of a polynomial in one variable is the greatest exponent. So the degree is the highest exponent, which in this case is 4. It's the exponent even on the leading term. So if you want that note, it's the exponents on the leading term. Next, we've got the leading coefficient is the number on the first term or on the leading term. Again, that definition is up here. So that number there is negative 2. So next, you're going to try one. You're going to want to tell me what it is in standard form, what it is the leading term. You're going to want to tell me what the degree is and what the leading coefficient is. So go ahead and pause the video and give that a try. All right, so once you have that done, you should have gotten negative 9x to the 5th plus 8x to the 3rd plus 4x squared minus 36. So our leading term is this first term of negative 9x to the 5th, meaning our degree, our highest exponent, is 5. And our leading coefficients, the number with the variable of the highest exponent, which is negative 9. So hopefully you got that. We are going to move on. So go ahead, you'll need to flip your page over here. So the next thing we're going to talk about is what's called end behavior. This is pretty straightforward. This is just looking and being able to identify the parts of your polynomial function. This part might be a little bit more confusing. So end behavior of polynomial functions. If the degree is even, so we have something like 2, 4, 6, 8, anything like that, and the leading coefficient is positive, so even and positive, then our function, so our function of x, our graph, as it approaches positive infinity, then x is approaching negative infinity. If we're looking at the other side, so this would be the right side of the graph. So we look at the other side, so the left side of the graph, we're going to write it as the function of x as it approaches positive infinity, x approaches positive infinity. So if it's even and the coefficient is positive, then this is what your graph is going to look like. So as your graph approaches positive infinity, then it's going to, your x values will approach negative infinity. and then vice versa for the left side. So if you're looking at the left side of your graph, it'll go towards positive infinity as you're looking the left side of the graph. I wrote this backwards, so hopefully you were writing in pencil. Think how to... I didn't write it backwards, I actually just switched this up on you. Okay, so I was looking at it, it's like, wait a second, something doesn't make sense. So it's the left side of your graph. So if you're looking at the left side of your graph, then you should be looking at... Okay, bear with me. We're going to start over because I said this wrong. So even numbers, still 2, 4, 6, 8, things that are positive. So let's rephrase this. As you're looking on the right side of your graph, okay, so if we think about our graph, I'm going to draw a graph over here, and our x values are on the right side as they get higher and then they get lower, okay? So that's what we're kind of thinking about. We're thinking about our function. We're looking from the left side of the function to the right side of the function. So the right side would be what's on this side. The left side would be what is going towards the left. So as our function is approaching positive infinity, where we're looking at the right side. So as our graph is on, as we're looking at our graph, if it's going this direction, that's what we're kind of looking at. So as our graph on the right approaches positive infinity, then we're going to be also our x values for the graph. I still wrote this backwards. Okay, sorry. I'm looking at like a different set of notes and I'm writing it backwards. So as our x values get larger, let me explain it this way, again with the graph. As our x values increase, so x approaches positive infinity, okay? As our x values get larger and larger and larger and larger and larger, then our graph, so our function, our polynomial, is also going to be approaching positive infinity. So in other words, our graph is going to be getting larger and larger and larger. Then if we look at the left side, as our x values are getting increasingly smaller going to the left, so they get smaller this way, and they get larger going to the right, then our function, so our f of x, is also going to be increasing. So our function, if I was to draw a function that is even, might be looking something like this. Notice both of our arrows are pointing in the upward direction. So positive infinity, again, the arrow on the left is also pointing in the upward direction. Okay, so let's move on to the next one. If the degree is even, so again, 2, 4, 6, 8, except this time I've got this word negative in here. So if I'm looking at my graph again, remember our x values as they get larger are going to the right. So as our x values get larger, so x values get larger, approach that positive infinity, then our graph is going to be approaching negative infinity. So that approaches negative infinity. Just try to write a sideways 8. So in other words, our arrow is going to be pointing in the downward direction. It's going to be pointing down. So then on the left side, as my graph, as my x values go towards the left, they get smaller. Then f of x, our function, our graph itself, are also going to be getting smaller. So it's going to be going down again. So that's an example of that graph there. So far our graph is looking like this or like that. So both down, both up. So if the degree is odd numbers would be something like 1, 3, 5, 7, 9, anything like that, and our leading coefficient is positive. Then I'm going to write it as, we have the right side, x approaches positive infinity. So as my x gets larger and larger and larger, as my x value increases, as my x value gets larger and larger and larger, going towards the right, then my graph is going to be getting smaller. So my graph, f of x, will be going towards negative infinity. So it's going in the downward direction. On the left side, got ahead of myself. There we go. On the left side, as x approaches negative infinity, remember those are the smaller numbers, then my graph is getting larger. So it's approaching positive infinity. So it's going up. So the left side would be going up. So this time I've got something that looks maybe something like that. I'm getting lower and I'm getting higher. Finally, I've got if it is a negative. So hopefully you're taking notice of these words here. So if I'm odd and negative, odd and positive, even and negative, even and positive, those are words that are important that you're going to want to pay attention to. So we're going to do this one last time. I've got that the right. So x approaches positive infinity. So as I'm looking towards the positive side, I'm going to notice that my graph is getting larger. So I'm going in the upwards direction. So my graph is going towards more positive numbers. So I'm getting larger. On the left side, as my x values get smaller, then my graph is going to be getting smaller. So I'm going to be approaching negative infinity. So this time I've got a graph that might look something like that. So notice each time we write the word right, you will want to put this on paper here. I start with x approaches positive infinity, and then f of x approaches something. When I'm looking at the left, I've got x approaches negative infinity, so I'm looking at the numbers that are going towards the left. Then my graph approaches something. This will either be positive or negative infinity, those blanks. So, as I do go through this, we've also got real zeros. So, the maximum number of zeros is equal to the degree of the polynomial. So if my degree of the polynomial is 5, the maximum number of zeros I can have is 5. So the max number of zeros is equal to the polynomial degree. And we are going to do more with zeros next week, so don't worry too much. So a 0 on the function is where it crosses the x-axis. So zeros are where the graph crosses the x-axis. So all I have to do is literally just count how many times it crosses the x-axis. Pretty straightforward, not much to it, which is awesome. So, like I said, we'll do more with zeros next week, but here's an introduction to it. So, determine whether the graph represents an odd or an even degree polynomial. So whether my degree is something like 1, 3, 5, or 7, or even, so like 2, 4, 6, or 8. And state the number of real zeros. So there's two parts to this question. Is it odd or even? Odd or even? and then the number of zeros. So first thing I'm going to want to do is I want to look as x approaches negative infinity. So I'm looking this time negative infinity. Remember, negative goes to the left. So I'm looking at the left side of my graph. Looking at this left side of the graph here. So as I go to the left, I'm going down. And if I'm going in the downward direction, if I go back up to the top and look, whenever I'm going down, I've got f of x is approaching negative infinity. So I'm going in the downward direction. So I can already say that I am either a negative degree with an even or a positive degree or a positive leading coefficient with an odd. So those are my two choices right now. I'm looking at the fact that it's negative and the fact that it's negative. So now I need to look at the other side. And I'm looking as x is approaching positive infinity. Remember, positive infinity goes to the right. So I'm now, for this one, I'm going in the upward direction. So I need something that's going down. And I just realized that I highlighted the wrong two things, so give me a second. So I'm going up here. So I need something that as I'm going to the positive direction, so the right side, if I was to fill this out, I've got x approaches positive infinity, f of x approaches negative infinity. Positive infinity. And then x approaches negative infinity. So then f of x approaches negative infinity. So I need a negative and a negative on the left. And the right needs to be a positive and a positive. So if I'm looking for positive on the right, I know that I am going to be here or here. And I'm looking for a negative and then the negative. So my negatives are here or here. So the only one that intersects then is this one right here. So it's asking me what degree it is. Is it even or odd? So I know the first answer is going to be that it is odd. The next one is I want to find out how many times it intersects the x-axis. Okay? So the number of real zeros is how many times it crosses or touches the x-axis. So I should probably add this, or touches. So the number of times it touches or crosses the x-axis. So if I'm looking at my graph here, I'm looking at how many times it goes across this line here. And when I do that, I find that it only crosses this one time. So how many times does it cross the x-axis? Just once, which means that there is only one real zero. That's all that there is to this. Okay, so I don't have another example like on here, but I'm going to draw one out for you because I think that we need to go over at least one more. So if I was to give you a graph that looked like this, and I wanted to say, is it even or odd? And I want to know the number of real zeros. Most important thing right now is I just really want to know, is it even or odd? I'm really worried more about the end behavior than the real zeros right now because we're going to do more with that next week. So we can start with the real zeros. That's the easier part. I'm looking at my x-axis and finding how many times it crosses. So I know it crosses 1, 2, 3, 4 times. So the number of real zeros is 4. Next, I'm going to look at the right side since I have it written right and then left. So I want to look at the right side of the graph. I want to know what it's doing. So on the right side of my graph, I have an arrow that points down. So that means as x approaches positive infinity, and I'm going to write that beside rather than underneath. Oops. Come on. Okay. So I'm just going to write this beside as x approaches positive infinity. So as I'm moving to the right on my graph, my arrow is going down. So that means my graph, my function, is also going to be negative infinity. So remember, down equates with negative. The left side then, I've got x approaches negative infinity. So I'm moving to the left now. I want to know what's going on that left-hand side of my graph, and it's also going down. So that means my function, my graph, is also going down. Remember, down is negative. Down is negative. If I was going up, like here, it would be positive. So that all being said, I can now go up to the top, and I'll use a different color than what I've been using so that we can find this. I'm looking for positive, negative on the right. So positive, so I'm looking for my negatives. So it can either be this or this. And then I'm looking for my left to also be negative. So my negative places on the left are here and not there. Here and here. So the ones that overlap then is the fact that I am even. So this is going to be an even function, an even degree. That's all this is. So go ahead. You might want to go through an Edpuzzle to get some more work on this. So maybe get another point of view other than my own. If you have questions, ask your questions. I have, I think, 2 examples on here for you to try out. Give them a shot. Do your best. You've got this.